This is video 17 in the thermal course, and this is about the general Gibbs Duhem equation, or this is general, and many Gibbs Duhem equations can be derived from this general equation. And this is also covered in chapter 11.3 in the textbook. The property M is a general property with a function of pressure, temperature, and the composition. The symbol here is the partial molar property. And with a partial molar property, that is the derivative of the total amount of the property when pressure, temperature, and all other components constant. And that is equivalent to state that the total amount of the property is the sum of the partial molar property of each component times the amount of all components. And because then M, the total amount, is a function of pressure, temperature, and all the amounts of all the components, then the D and M can be expressed as the change in the total amount with regard to the pressure, then the temperature, and all the components are constant, plus the change in the total property with temperature, then the pressure and all the amounts are constant. That is the change with temperature, and we can also let all the amounts change. So that is when we change all the possible variables that N is a function of, and that is equation 1. then we are taking the total differential of D and M. This is an expression for the total amount as a function of the partial molar properties and the amount of each component. And that can be divided in two sums. It is the sum of the amount times the differentials of the partial molar property, and it is the sum of the partial molar properties and the change in amount. And this is an expression 2 of D and M. Then we subtract 2 from 1, and then we get the change in D and M with pressure, with the temperature, and the composition constant, plus the change with temperature, when the pressure and the composition constant, and then we change the temperature. And because we have the total sum here, the total, and then we divide it into here, we end up with the sum of the amount times the change in the partial molar property for each component. These parts of the equation shall be 0. Then we divide by n. We have n in the two first parts, and then we get a change in the property with P, keeping the temperature and the mole fractions constant, and then we can change the P, plus the change in the property with T, keeping the pressure and the composition constant, times dT, minus the sum of x. Ni divided by n is xi, the mole fraction, times the change in molar partial property. And the sum of this should be 0. And this is the result. This is the general Gibbs Duhem equation. It is equation 1113 in the textbook, which is valid for any state function that is typically enthalpy gives free energy, and this is a very general equation, and is showing the change in the partial molar property of any component related to the change in pressure and related to the change in temperature. And this is general. For the special case, that the property M is G excess over RT, and the pressure and the temperature constant. Then we have the connection that the sum of mole fractions and the change in the logarithm of the activity coefficient should be 0. Now we have gone to equation 11,100, but I go to this equation because this connects the change in the activity coefficient with composition, and this is a useful special Gibbs Duhem equation. Now I have been through the derivation of the general Gibbs Duhem equation. From a mathematical point of view, it is not especially complicated if we accept that we define a partial molar property this way, and that the total of a property is the sum of the partial molar properties and the amount. Because this is just a general expansion of a function, this is a total differential, and then by mathematical manipulations we end up with this Gibbs Duhem equation, and this is actually a strong equation connecting different the property at different conditions, and we have one direct application with the connection between the activity coefficient and composition. That is the end of the video.